Welcome to AI Scrutinised, the YouTube channel which aims to study, investigate, analyse and evaluate all things AI. The dream of artificial intelligence is thousands of years old. Long before computers, before electricity, before anyone knew what an algorithm was, humans imagined creating mechanical minds. This is how ancient myths became modern reality. I'm Ian, and in today's episode we begin our journey. This is the AI story, starting with From Ancient Dreams to Modern Foundations. Let's start 2,800 years ago in ancient Greece. The Greeks didn't just tell stories about gods, they imagined artificial beings, built with purpose. Talos was a giant made of bronze, who patrolled the island of Crete. Essentially, it was an autonomous security system. Hephaestus, the divine craftsman, supposedly built golden mechanical servants who could anticipate his needs and assist in his forge. Pandora herself was described as an artificial woman, crafted by the gods and given specific programmed traits. Now these were myths, stories if you like, but they reveal something profound. Humans have imagined creating autonomous intelligent beings for at least 2,800 years. And the Greeks didn't only dream, they built. Around 60 CE, Hero of Alexandria created programmable automata, temple doors that opened automatically when fires were lit on altars, mechanical birds that sang, even an early vending machine. These weren't intelligent, but they were programmable, in the sense that they followed encoded sequences of actions. This is crucial, the idea that behaviour could be mechanised. And the Greeks weren't alone. In ancient China, around 900 BCE, legends speak of Yang Xie, an engineer who allegedly presented a life-sized humanoid automaton to King Zhou Mu Wang that could walk and perform. In the Islamic Golden Age, around 1200 CE, the scholar Al-Jazari designed remarkably sophisticated automata, programmable humanoid musicians which were water-powered devices with adjustable timing mechanisms. His book of knowledge of ingenious mechanical devices influenced European engineering for centuries. These weren't AI, but they established a critical principle. Complex behaviour could be generated by mechanical rules. But to build an artificial mind, you first need to understand what is thinking. Aristotle helped to influence logic. His syllogisms showed that reasoning follows rules. Structured, predictable mechanical rules. An example of this was his statement, "All men are mortal, Socrates is a man, therefore Socrates is mortal." This matters because modern AI, especially symbolic AI and expert systems, still use exactly this kind of rule-based reasoning. In summary, Aristotle was the first to suggest thought could be formalised. Around 1305 CE, the philosopher Ramon Llull created something extraordinary: mechanical logic wheels covered in symbols representing concepts: God, truth, beauty. By rotating these wheels, Llull believed he could generate all possible true statements about the universe. It was called the Ars Magna, the Great Art. While it didn't work as intended, Llull had stumbled onto something profound: combinatorial reasoning, the idea that complex thought might emerge from combining simple elements, according to rules. This is conceptually similar to how modern AI searches through possibility spaces. René Descartes made a controversial claim: animals were essentially biological machines, complex automata with no souls, operating purely by mechanical principles. While deeply wrong about consciousness, Descartes established that complex behaviour didn't require divine intervention. It could emerge from mechanical processes. This mechanistic view of life would eventually extend to the human mind itself, making AI conceptually possible. Thomas Hobbes went even further. In 1651 he wrote, "Reason is nothing but reckoning." Think about that. In 1651 Hobbes proposed that human thought was computation, adding and subtracting concepts according to logical rules. This is the philosophical foundation of AI. If thinking is calculation, then machines that calculate might eventually think. Leibniz envisioned something he called the calculus ratiocinator, a calculus of reasoning that would let people resolve philosophical disputes by sitting down and saying, "Let us calculate." He imagined a universal symbolic language in which all human knowledge could be expressed and mechanically manipulated. He even built mechanical calculators such as the stepped reckoner, which could perform all 4 arithmetic operations. Leibniz essentially described symbolic AI in the 17th century. Philosophy is one thing, but what about actually building these machines? Among Leonardo da Vinci's thousands of sketches is something remarkable: a mechanical knight designed around 1495, which was capable of sitting, standing, moving its arms and even turning its head. It was powered by pulleys, gears and cables hidden inside the armour. Leonardo wasn't trying to create artificial intelligence, but he was doing something crucial: decomposing human movement into mechanical operations. This is a roboticist's mindset, breaking down complex behaviours into simple, reproducible mechanisms. Jacques de Vaucanson built automata so lifelike they shocked audiences. His mechanical duck could flap its wings, eat grain, digest it chemically and, well, excrete. His flute player actually blew air through a real flute to create music. These weren't puppets, they were attempts to replicate biological processes mechanically. Vaucanson was asking how much of life could be recreated by machinery. Perhaps most impressive were the Jacquet-Droz family automata. Inspired by the watchmaking skills of Pierre Jacquet-Droz, the writer, using a system of cams, could be programmed to write any text up to 40 characters. The draftsman could draw 4 different pictures, and the musician actually played a real organ. These were mechanically programmable machines. By rearranging cams, you changed their behaviour. This helped to influence what would become stored program computing in 1774. By the 1800s, a mathematical revolution was underway. In 1854, Boole published The Laws of Thought, showing that logical reasoning could be expressed as algebra, and, or not, became mathematical operations. True and false became 1 and 0. Now, this seems simple now, but it was revolutionary. Boole showed that thought itself could be calculated. Every computer chip, every algorithm, every neural network ultimately speaks Boolean logic. It's a universal language of computation. Gottlob Frege, symbolic logic notation. Frege went further, creating predicate logic, a formal system that could express complex relationships. For all x, if x is human, then x is mortal. This became the foundation for knowledge representation in AI, expert systems and logical inference engines. Frege gave AI a way to encode meaning. Charles Babbage, 1791 to 1871. In the 1830s, Babbage designed the analytical engine. It had a store for memory, a mill for processing, conditional branching, and was input via punched cards. It was never built in his lifetime, but the design was complete. This was a general purpose computer, theoretically capable of running any program. Without Babbage, there's no computer, and without computers, there's no AI. But it was Ada Lovelace who saw furthest of all. Lovelace was a mathematician and Babbage's collaborator. In her notes on the analytical engine, she wrote something extraordinary. The engine might compose elaborate and scientific pieces of music of any degree of complexity or extent, supposing that the fundamental relations of pitch sounds were susceptible of such expression. Now, in essence, Lovelace was proposing that any process that could be expressed using abstract symbols and rules, whether mathematical operations or the principles of music composition, could be executed by Babbage's machine. This idea is now seen as an early prediction of modern computing's versatility, suggesting that computers are general-purpose information processors, not just giant calculators. She envisioned machines that could create art, machines that could work with symbols and not just numbers. Ada Lovelace described artificial creativity in 1843, a century before computers existed. By the 1930s and 1940s, the final theoretical pieces were falling into place. Kurt Gödel in 1931 showed there are limits to what mechanical systems can prove, defining the boundaries of computation. Alan Turing in 1936 defined the Turing machine, answering the question, what can be computed? In the 1930s, Norbert Wiener explored feedback loops and control, sowing the seeds of cybernetics. By 1940, every conceptual piece was in place. Logic had been formalised, Aristotle to Boole to Frege. Computation had been theorised, Babbage to Turing. Limits had been understood, Gödel. Feedback and control had been explored, Wiener. The hardware just needed to catch up. Then came World War II, and the desperate need for computing machines would finally force theory into reality. At a secret facility called Bletchley Park, a young mathematician named Alan Turing would build machines that could reason. They would crack Nazi codes, shorten the war and save millions of lives, and prove that machines could manipulate knowledge at unprecedented scale, setting the stage for artificial intelligence. Next time, the war machines that started the computer age. Thanks for watching. If you enjoyed watching this video, please hit the like button, as it really helps the channel to grow. By also hitting the subscribe button, you'll be notified when the next episode is ready to watch. Don't worry, subscriptions to this channel are free. This is the AI story, and we're just getting started.